Hello, Algebra 2. This is our video lesson for 8.7, which is dividing rational expressions. These are the 4 steps that we're going to use to divide rational expressions. So let's just go over them real quick. Step 1, we're going to leave the first fraction, that's the one on the left, leave that one alone. We're going to reciprocate the second fraction and change the operator. Let's go over a couple of terms over there. What do I mean when I say reciprocate? When reciprocate is just going to be flipping the fraction. So what is the reciprocal of 1/3? 3 over 1. How about the reciprocal of 1 over x? Well, that reciprocal would be x over 1. What if I had y over z? What's the reciprocal? If I were to reciprocate that fraction, y over z, I just flip it and I get z over y. That's what a reciprocal is. That's what it means to reciprocate a fraction. What about operator? What do I mean about changing the operator? Well, the operator is just the plus sign, the minus sign, the multiplication sign, the division sign. In this case, since we're dividing rational expression, our operator is the division sign. But after we reciprocate, we're going to change that, and we're going to change it to multiplication. Okay? So we're going to reciprocate, and then we're going to change the operator from dividing to multiplying. Step 2, we're going to factor each expression in each numerator and each denominator completely. Step 3, we'll rewrite those two fractions as one fraction. And then finally, step 4, we're going to simplify. Okay, so I'm going to erase this here so we can get to work on our first example. Now I'm going to go ahead and pause and write that down. Okay, on to example 1. Example 1, we have 7x squared over 6 divided by x over 2y. Okay. Step 1, we're going to leave the first fraction alone. We're going to reciprocate that second one. So we're going to leave this first one alone. It's going to remain 7x squared over 6. We're going to reciprocate that second fraction, which means it becomes 2y over x. And we're going to change our operator. It's no longer going to be a division problem. It's going to be a multiplication problem. So now we have 7x squared over 6 times 2y over x. Yep. We're going to factor each expression in the numerator and denominator completely. But looking back, we have monomials in the numerator and the denominator in each fraction. So they're factored completely. There's nothing we can do there. So we'll move on to step 3, which is to rewrite it as one fraction. So we're going to have 7x squared times 2y over 6x. Okay, is there anything that we can cancel out here? Well, let's see. I have x squared up top and x on the bottom. So I can cancel out the x on the top, and that x squared just becomes, for the x, so I can cancel the x on the bottom. X squared on the top just becomes a single x. I have common factors in 2 and 6 with 2. That 2 will go away, and I'll be left with 3 on the bottom. So now that I've canceled out those terms, I'll be left with 7xy on the top, and on the bottom, I will just have 3. So my answer to example 1 is 7xy over 3. Let's take a look at one more example. Example 2, you'll have 10x plus 4 over x squared minus 4, and we're going to divide that fraction by 5x cubed plus 2x squared, and that will be over x plus 2. Okay. So step 1, we leave our first fraction by itself, or we'll leave it as is. We're going to reciprocate that second fraction, which means we're going to flip it. So this now becomes x plus 2 over 5x cubed plus 2x squared. And now we change that division operator. We change it. It now becomes a multiplication problem. All right, step 3, we factor each expression in the numerator and the denominator completely. Can we factor this one? Yep, there's going to be a greatest factor of 2 coming out of that one. Can we factor this one here? Yes, we can. That's actually a difference of squares. Can we factor this here? No, x plus 2 is as simple as it gets, so that's not a factorable expression. And how about here? Can we factor this one? We're going to be able to pull out a greatest common factor of x squared out of that expression. So let's start with this one here. We said we had a greatest common factor of 2. So we'll factor 2 out of 10x plus 4. We will get 5x plus 2 for that numerator. We have a difference of squares down here. So we're going to have x plus 2, x minus 2. We are multiplying. So we're going to have x plus 2 up top. I'm going to use my parentheses so I don't get in trouble. And I'm going to factor a greatest common factor of x squared out of here. So when I factor x squared out of 5x cubed, I'm left with 5x plus 2. So I've factored each numerator in each denominator, and I have that right there. Now I have to rewrite this as one fraction. I can probably just get rid of that, or I can just get rid of that multiplication operator and extend that fraction bar all the way across. Now I need to start canceling out common factors. I have a common factor on the top and bottom here of 5x plus 2. So I can cancel that out. I have a common factor of x plus 2 on the top and bottom, so I can cancel that out. I think that's about as far as we can go. So I'll be left with 2 in my numerator, and then on the bottom, I'll be left with x squared times x minus 2. Make that a little bit clearer. That's a 2. So my final answer for example 2 is 2 over x squared times x minus 2. So hopefully those two examples kind of show you how to work through those 4 steps when you're dividing rational expressions. If you run into any troubles, please email me. Otherwise, go to your homework.